Hello friends, welcome to Chance Code. Java 13 got released few days back and one of the most important feature it brings to the table is switch expression. In this video, we are going to explore this feature of Java 13 and understand what it is. In addition to its usage and syntax, our focus on this video will be how it works internally and how it is different from the traditional switch statements. Before moving forward, I would like to say that if you are new to this channel, please do subscribe to it for this kind of videos. So let's get started without waiting further. I have taken this small example of traditional switch statement, whose equivalent bytecode looks something like this. If you are wondering what table switch is and what are these L1, L2, L3 and L4, I have made a separate video on how switch statements work under the hood. You can find the links to that video in the description below or in the info card above. Please watch that first to understand further parts of this video. Now coming back to this example, it has fall through mechanism. This means the control flow falls through each case from the matched one. But these kind of switch statements are rarely used in high-level programming languages like Java. Because most of the time we don't want control flow to fall through each and every case from the matched one. So we usually use switch statements with break. And these break statements introduce few more labels in the bytecode like this. This switch statement works just fine. However, there is a possibility of missing break statements which might end up in having different results. Moreover, the break statements are explicitly needs to be mentioned here, which ideally should be implicit. To solve these problems, now Java has switch expressions which looks like this. And if you look into the bytecode of this switch expression, it looks almost same as the bytecode representation of equivalent switch statement. But there is a minor difference. And that is, instead of having two additional labels like L5 and L6, the goto commands are now inlined with L1 and L2 block. And the reason behind that is switch expression doesn't have any fall through mechanism, and by default every case label has break inbuilt into it. Hope you now understood the given switch expression and its equivalent bytecode are same as this switch statement and its bytecode. Now we are quite clear how Java has implemented the switch expression by slightly modifying the equivalent bytecode of switch statement. So far we have discussed only one type of switch expression. Now let's slightly modify this switch statement like this. As you can see, in addition to the explicit break statements, we also need to mention case for both red and green label even though their code is same. Certainly there is a room for improvement in this switch statement. So this can be written in switch expression way like this. In this switch expression, we have got rid of break statement as well as the case word prefixed with respect to the green label. Definitely this became a readable code, and in addition to that, it is less error prone. Now if we see the bytecode of this switch expression, we can easily say that instead of having an additional label like L4, the goto command goes inline to the L1 label. And this is another way of using the switch expression. So far we have seen two examples where we simply wrote some code as part of case labels. Now what if we want to assign some variable based upon the case label? In that case, our switch statement will look something like this. And in this example, I have declared a variable called result which is outside the switch statement. And the same way, bytecode of it is also outside the table switch command. And in every case, we are assigning some constant to this variable. Notice that in all these four statements, we are loading a constant and assigning or storing those constant into the variable. So their bytecode equivalent will be iconst and istore, where iconst is meant to load a constant, where istore is meant to store that constant into a variable. So here is the final bytecode representation of the corresponding switch statement. It is clearly noticeable that every case label has some boilerplate code, and that is assigning the constant values to the variable result and break statements. So this can be converted into switch expression like this. And here we got rid of assigning the constant to the result variable in each case label, as well as we got rid of the break statements. And in addition to that, we can see that the switch expression is returning the constant and assigning to the result variable. Now let's see how its bytecode looks like. Since there is no variable declaration outside the switch expression, so we can get rid of its equivalent bytecode. Now let's look into each case label. And if you observe, we are just loading the constant and we are not storing those things into the result variable. So their equivalent bytecode will have only iconst command and there is no istore command. And as there is no break statements, so L5 and L6 levels are gone and these goto statements will be inlined. Now the question is where these constants will be assigned to the result variable. Since the assignment is done only once instead of having it in all case labels, so a new label is added to store the value after the last case label. And the goto command of L1 and L2 will jump to the newly introduced label. Now there is one more problem, and that is we don't have a default case here. So in addition to L5 label to store the result, we have L4 label which throws an exception. Now the question is why L4 label throws an exception instead of ignoring it the way it was ignored in the case of switch statement. And the reason is switch expressions are exhaustive in nature. That means you are forced to write each and every case label including the default. Now there is one more problem, and that is when the color is blue, it will always throw an exception. So even though blue is the last case label, compiler has to introduce goto in this label as well. Now let's see what if we are ignoring one case label in this switch expression. We know that switch statement it is okay to ignore any case label, but because the switch expressions are exhaustive in nature, compiler gives an error in this case. So to avoid this compilation error, either you have to write the default case or maybe the last case label, and the bytecode equivalent will look something like this. So this is the way how switch expression returns a value from it. Now you might ask, what if I need to write some code in each case label, evaluate a value and then finally return it? So to understand this use case, let's go back to our switch statement example. And in this code, in addition to assigning a value to the result, we have some more code to evaluate the value. So obviously the bytecode of this will look something like this. Now how do you write the same thing in this switch expression way? Since we have to write some code, let's break into multi-lines. And here is our code. But guess what? Our compiler is not happy in this case. It gives an error saying the constants what you have defined is not a statement because it is not assigning to any variable. And to avoid this situation, Java 13 has introduced a new keyword called as yield. And by using yield, we can return these constants from the switch expression and assign it to result variable. Now let's look into the bytecode and understand what it has changed by the introduction of yield keyword. Since the upper part of the bytecode, which is table switch command, is not going to change anymore, so we are going to remove this for the presentation purpose. Now let's add the equivalent bytecode of the code we have written in each case label. Since the yield is a keyword and explicitly mentioned to return from the switch expression, so compiler is going to introduce the different labels to represent it. We can clearly observe that L7, L8 and L9 are look something similar to the break statements of switch statement. You can definitely change the switch expression into any permutation combination way and try to use it. For example, let's say green label doesn't have any code and instead it just returns or yields a value out of it. So the equivalent bytecode will look something like this. You can see that L2 label, which was representing the additional code of green label, is now no more. If you don't have any additional code with respect to a label, you can simply mention the constant value with respect to it. And in this case, the L9 label, which was representing the yielding of the value from blue case, is now no more and it is inlined with L3 case label. Hope you now understood how to use Java 13 switch expression and replace it with your current or existing switch statements. And in addition to that, hope you understood how Java compiler is smartly changing the minor modifications in bytecode to achieve the switch expression. And on top of it, just because Java 13 has introduced switch expression, it doesn't mean that switch statements are no more. They are still in the Java ecosystem and you can definitely mix and match both switch statement and switch expressions in your project. Moreover, you can also yield something from a switch expression in the traditional way of case labels. Hope this video was useful and you have learned something new out of this video. And if you liked this video, please do like, share and subscribe to our channel if you are new to this channel. Thank you. Thanks a lot for watching.